Hello, I'm Dr. David Kordowitz and welcome to Programming. Today we're going to be talking about libraries. Libraries are a method that you can take multiple functions and put them into a single file such that you can reuse them between different programs. Let's begin. So previously we had talked about the idea of code reuse in functions. So we talked about that you can use functions to serve certain purposes that need to be done repeatedly. These functions allow you to write the code once and reuse it not only within the program you've written, but in other programs. However, when we think about it, the way that we've described functions, to move them between programs, you would have to copy the code and paste it into the code of the new program. This probably isn't the most practical thing when you're trying to reuse code. Instead, we have a mechanism called libraries which allow us to take these functions and reuse them between different programs without having to rewrite the text or copy and paste the text between the different programs. Libraries can be broken up sort of into generally built-in libraries and then user-created libraries. Now, in the user-created side, we're talking about things also which you've gotten from third parties, such as drivers for hardware and things like that. Built-in libraries, for example, are things like stdio, stdlib, math, any of those things that you've used in the past. And then user-created libraries can be pretty much whatever you want. You can write them yourself, you can get them from vendors and things like that. These libraries can give you much extensibility to the language and give you very much the ability to build what you really want to have. So let's take a look at sort of how libraries work. In general, a library consists of two files. The first is a header file or a .h file. The second is an implementation file, which is a .c or .cpp file. Now, when we're talking about libraries in terms of C and C++ for standard programming, they're a little different than they are for, say, Arduino C. So we're going to discuss the Arduino side, and if you would like more information on the C or C++ side, there are plenty of resources available. Now, the header file is going to contain the function declarations. Previously, we had put those at the top of our files. So now we have a separate header that's going to contain these declarations. We then have an implementation file, which is going to contain the actual code for the functions. So this is where we actually put what we're trying to do. Now, when we want to use a library, we simply include it into our program. We've seen pound include before, but we haven't really talked about it or what it does. What it allows us to do is bring the libraries into our code and actually add that particular code to the code we're writing now. Now, you may see differences between dynamically linked and statically linked libraries if you look in the literature a little bit. But for now, let's not worry about that because it goes beyond the scope of anything you could do on an Arduino. So what we do is we include the library. Now, if you notice, sometimes you use quotation marks and sometimes you use triangle brackets or angle brackets. The general idea is that the angle brackets are when the library is located in one of the standard library paths. Typically, this is on Linux/lib or can be in other places depending on your operating system. Now, when you put the triangle brackets, the preprocessor is going to look at your code and say that the library must be in that folder and grab it. The quotes are a little more flexible. They allow you to look elsewhere in a number of directories that are specified to the compiler. Typically, though, it's going to start by looking in the same directory with the code you've just written. So this allows you to include two separate ways and be able to use libraries depending on where they're located. Now, typically the triangle brackets will define one of those system libraries that come with the system or built-in libraries, and the quotes are going to represent user-constructed libraries. Now, in Arduino, you get a little more flexibility that it probably will accept quotes or triangle brackets for most types of libraries. However, it's useful to stay with the convention just to keep your code straight and make sure that it works on all compiler configurations. So let's dig down a little bit. The header file basically is going to contain your declarations. Now, your header file basically needs to have a mechanism to tell the compiler, hey, this is my library and we've loaded it. And so compilers tend to be kind of dumb about this and don't know if the same library has been loaded over and over and over again. And should this happen, you're going to get cyclic loading errors, and you're going to get linker errors, which are incredibly hard to figure out. So typically we're going to use what we call a macro guard. And what a macro guard is you're simply adding some code to the beginning and end of your library to prevent it from being included multiple times. So if we look at the code on the right, we start with if ndef, which means if not defined, header underscore h. Then the next line is define header underscore h. We then have our code and we have our end if. So what happens is if header h is not defined, we're then going to define it and execute our code. If it is defined, this whole program or this whole file will look blank to the compiler. So it basically will skip the file and won't include it a second time. Now the convention is that when you're doing macro guards, that you use the name of your header file underscore h all in capitals. Now you don't have to do that. However, it's useful for you to use some sort of convention to name these macro guards so you can keep track of them in your programs. We then have our .c or cpp file. It's .c if you're writing it in strict C, and .cpp if you're writing it in C++. Now the implementation file will always begin with including your headers. So in the case of our previous one, we have myheader.h, which is going to contain a function called flip, which is a coin flip in this case. And our myheader.cpp begins with #include myheader.h. Now it's important on Arduino that you include Arduino.h, otherwise you're going to run into compiler errors. This is not true in other C and C++ compilers. There are other things that may or may not be required to be included depending on the platform you're running on and whether you're using pre-compiled headers or standard headers. Basically, you then can systematically implement your code. So in this case, our coin flip takes a random number between 0 and 1, and if it's greater than 0.5, it's going to give you 0, otherwise it's going to give you 1. Now, it's important to note here that there's going to be an ever so slight bias towards 0 because of the values that we've chosen. You can also add functions in the headers.cpp file if you want to that won't be available to the outside world. So if you have some sort of process or some sort of mathematical application that you want to do that you don't want available to your end user, you can bury it in your myheader.cpp or your .cpp file. This is not conventionally used, however, it is definitely available and people do use it in their code. So let's talk about a couple little Arduino specific things and then we'll get to an example. So in the Arduino world, you're going to have a directory on your computer that is created in your My Documents folder or in your home directory should you be using Linux or Mac. And this directory is going to be called Arduino. Within this directory, you're going to have a folder called Library. You're also going to have folders for every sketch that you've ever written on that computer. This libraries folder is then going to contain a bunch of other folders, each one for a different library. So when you write libraries, you're simply going to make a directory for the library you write and stick it into this folder. This will automatically inform the Arduino IDE that this library is valid and available, and it will add it also to the include library menu item up on the top of the screen. There's additional information you can add, such as keywords and information, as well as descriptions and things like that. These are really nice to add if you want them. However, they're not required to work in the Arduino IDE. So if you want them, add them. If you don't want them, don't add them. Within your library folder, you can also include a directory called examples. If you do this, any code that you put in there as examples will show up in the sketchbook examples option in the menu at the top of the screen. Okay, let's try this out. For today's example, we're going to be building a unit conversion library for converting units of volume. So to create this library, we need to create a header file and an implementation file. So to create the header file, I'm going to come over here in my Arduino IDE and I'm going to pull down on this arrow on the right hand side of the screen. I'm going to choose New Tab to create a new file, which we're going to call convert volume.h. So that's going to be our header file. And now we need to start our header file by building our macro guard. So to build the macro guard, if you remember, we start with pound if ndef, and we then use the file name. So I'm going to use convert v_h. This is just convention. If you remember, you can use whatever you want as your macro guard as long as it is unique. And then we can do pound define convert v_h. And so basically what that is saying is it's saying if it doesn't exist, then create it. And then we end with an endif. Now, what it means is that if it is defined, it's going to skip this entire block. And as far as the compiler is concerned, your code doesn't exist in this file, which is a good thing. It's going to keep you from getting multiply defined. So we're going to add some really basic conversions here. So let's start with double. And let's start with cubic meters. So M3 to, and let's go to liters first. So to liters, and then what we need is our input is we need to get what our input value is going to be. So let's make that a double. And we're going to call it input. That's our first function. Now let's create a second. M3 to gallons. That would be useful for those of you who are converting from English units and SI units. We can go ahead if we want to and make the reverse. So we can make the reverse these. So copy and paste. And we're going to do L to this. And then we're going to do gallons to meters cubed. All right, let's do a couple more interesting and creative units here. So let's use, for example, a Royal Albert Hall. Royal Albert Hall is a unit of measurement, typically in the UK, measuring volume. And one of the things they discuss about when we talk about a Royal Albert Hall is the song A Day in the Life by the Beatles, where they refer to a Royal Albert Hall as a unit of volume. And the Royal Albert Hall is somewhere on the order of 99,000 cubic meters. So let's do a double, and we're going to do M3 to RAH, and we're going to take a double input. And then for good measure, let's go the other way. And so we're going to say RAH to meters cubed, double input. And finally, let's do Grand Canyons, because Grand Canyons is a great great unit for those of us here in Arizona. So we're going to do double M3 to GC. And then the Grand Canyon is 4.17 trillion cubic meters. So we're going to do double input. And let's do the reverse. Okay, so we now have our header file, so we're going to go ahead and save this. And now we need to create our implementation file. To create our implementation file, all we need to do is go back to our arrow, pull down, and do another new tab. We're going to call this convert v.cpp. So this is our implementation file. And if you remember from our discussion previously, we need to include our header first. This is going to bring all of our function prototypes over. We then need to include Arduino.h. If you don't include Arduino.h, your library will not successfully compile, and it will give you a bunch of errors which will be confusing. So now the easiest thing we can do is come over to our header file and copy our values from over here for our prototypes and paste them back into this file. This is one of those cases where retyping it can lead to errors, which will lead to problems later on, so it's much easier to just cut and paste to guarantee everything will be the same. Now we're going to take the first one, delete the semicolon, and we're going to implement it. So we know that cubic meters to liters, there's 1,000 liters per cubic meter, so we're going to say return 1,000 times our input. And that's all that function is. If we want to do our reverse, which is going to be liters to cubic meters, simply delete that, and we're going to return input divided by 1,000 because we're going the other way. So we can implement the rest of these quickly and be able to use them in a program. Our implementation file is now complete. One thing I'd like you to notice is that I used E notation for our returns on the cases that we had 4.17 trillion because writing out 9 zeros would just seem to take a lot of time to do. So now when we want to develop this and we want to actually start writing code with this, we can temporarily leave them where they are if we would like to, or we can move them to the library file as we should. So let's go quickly and look at how to do this. So I'm going to open up a Explorer window here on my Windows machine, and we're going to go to our Documents folder and then to Arduino. We're then going to go to Libraries, and we're going to create a folder in Libraries called convert.v. Within this folder now, we're going to go ahead and copy our two files, our implementation file and our header file. So to do this, again, we're going to go to Documents, and we're going to go to Arduino, and we're going to go to the sketch that we're working within, which is this one here, and I'm going to copy the convert.v cpp and the convert.v h. I'm going to copy those into the folder we were previously in. So I can back this out and paste it here. Now that we've restarted our Arduino IDE, if we notice, we can now go to our sketch include library, and if we scroll down a little bit into our libraries, we should see in the contributed libraries, we should see our convert v. If I click on that, it'll simply include convert v. Okay, so let's just take some really basic tests here. So let's start with our setup, and we're going to say, okay, serial.begin, 9600, and then we're going to have a while not serial, and we're going to conclude this with a serial.println. And let's simply do first a meters cubed to liters, and let's just do 1 and see what our results look like. We're going to compile this just how we would normally compile any other code. We may run into an error here due to the library, due to there being a copy of the library in both the libraries folder and in the folder we're working in, which is in fact what has shown up here. So what we need to do now is go ahead and delete these two files. So we're just going to hit delete. We're going to go to the tab delete, and we're going to go to the tab here and delete. This is going to remove these from our project so we don't have multiply defined functions. We now click the next button, and our code should compile. It writes to hardware, and if we open the serial monitor, we get 1000, which is what we expect. Now that our library is working and tested, let's see how the Beatles statement in A Day in the Life holds up. The lyric is 4,000 holes in Blackburn, Lancashire, and though the holes were rather small, they had to count them all. Now they know how many holes it takes to fill the Albert Hall. So let's see how many holes it takes to fill the Royal Albert Hall. So let's start out by first computing the volume of one Royal Albert Hall. So let's use double to do this, and we're going to call it RAH, and we're going to say we want to go from RAH to meters cubed, and we want 1. So now we're going to also look at what the volume of a single pothole is. I've taken the liberty of looking this up on the Royal Auto Club, and I've gotten some dimensions. We're going to assume that the pothole is a cylinder for the purposes of this calculation. So the average depth of a pothole in the United Kingdom is somewhere on the order of 40 millimeters. Now, if we want to convert this into meters, all we need to do is divide it by 1000. We have a problem here, however, that this will perform integer math. So I need to put 0.0 on the end of it so that the 40 becomes a double, and now the mathematical operations will be double. The average diameter of a pothole is somewhere on the order of 600 millimeters, which will be 60 centimeters, or about 2 feet if you're using the English system. And then we're going to divide this again by 1000. To compute the volume of a cylinder, if we remember from mathematics, is simply to take the area of the circle, pi r squared, and multiply it by the height. So in this case, we're going to say double pothole is going to be equal to pi, which we've defined at the top of our screen, times the radius, and the radius is simply going to be our diameter, divided by 2, and we want to square that. So we're going to do pow, parenthesis, the diameter, divided by 2, comma 2. So there's pi r squared, and that's going to give us our area. Now we simply multiply that by the depth. All right, so that's going to give us the volume of a single pothole in meters squared. Now to compute how many potholes would fit in the Royal Albert Hall, all we need to do is divide the volume of a single Royal Albert Hall by the volume of a single pothole. So we're going to do this for a shortcut in a serial.println, and we're going to say, okay, well, 1 RAH divided by pothole. And so now that should print to our serial monitor how many holes it takes to fill the Royal Albert Hall. If we compute this, give it a second to to compile and write to hardware. So we get infinity, and that's because, again, this 600 needs to be 600.0 to get out of integer math. Let's try it again. We get somewhere on the order of 87.5 million potholes. That said, I don't think 4,000 holes would actually be all that much volume compared to the Royal Albert Hall. This thus disproves the lyric from A Day in the Life. This completes the Arduino C portion of this course. We'll continue forward using MATLAB for future activities. The next video will introduce MATLAB to you and get you started. I'd like to thank you for your time today, and see you next time.